Good afternoon. This is Bill Anderson, coming from beautiful Austin, Texas. Everyone's doing well today. I have a short presentation for you. It'll be under 30 minutes, in respect of your time. Talk a little bit about the lessons learned 10 years later from the Pentagon 911 disaster. I was privileged to be one of those that got called. We all remember the events and probably where we were, what we were doing, who we were with, how we responded. And our world was kind of devastated for a while, and a couple of days later I got a call from a Pentagon general asking if we wouldn't come in and bear a hand in helping them recover communications. It was obviously a very proud time in my life to be prepared and to be asked to serve in that capacity. Responded and came and helped out as best we could. Analyzed a lot of various problems. We looked at various communication circuits, network management systems, security infrastructure, pretty much the whole gamut of IT. We analyzed, we asked, we looked at, and we prepared a 100-page report for them so that they'd know the results of our analysis and then how to proceed with that information. So, organization serves large-scale environments, the Global 1000, military, government. In the last 10 years, we've gone into Iraq half a dozen times and Afghanistan and helped diagnose problems across the entire war environment and been back to the Pentagon to analyze other things. That's the nature of our service, is high visibility, large scale problem type environments. In 20 years, diagnosing critical problems down to the technical cause, we've learned a few other things. We've learned that it's not just the technical problem we want to avoid, but the processes which lead to the ability of those technical problems to exist. So essentially, our root cause is changed from technical root cause back into the best practices that obviate those problems. We look back and find what processes were omitted or not in effect. And typically, I got a CIO whose enterprise was just melting down, and we diagnosed the problems, mitigated the problem, and of course, they have to ask, well, what can we do to prevent? So not only in the last 20 years have we been diagnosing critical problems, but we've been analyzing what kind of procedures, processes, and systems of those critical problems to exist. And so that's kind of the way that we're moving forward with the new Apoletics Corporation, is to help people mitigate and identify those things that they can do that will avoid crisis and avoid problems. So I hope you came to learn a little bit and to just see my perspective and that sort of thing. Now, what we've done is we've kind of taken all of these lessons learned, and we call this technical systemization. And there are pillars to technical systemization. And we're going to go through some of those pillars today because they directly relate to the events of 911 and pretty much any other type of disaster, and taking the lessons learned and applying them. Now, technical systemization is very much an implementation. ITIL is a model. ISO has models, and we have protocol models. We have the OSI the OSI model. Well, The AI model is just that. It is a model. It is not an implementation. And so I want to make and draw a distinction between that of a model, like ITIL is a model, the OSI model is a model, but an actual implementation such as IPX or TCP/IP or AppleTalk, those are true implementations. So, and they look different from the model because they are applied to your exacting problem and your exacting environment in such a way as to have teeth to make things truly work. So by changing the name of your organizations to model, to be the same as, for instance, the ITIL model, is not necessarily implementing a technical systemization that will allow that to work. So that's part of our message. Each institution needs to have their own technical systemization. Their implementation of ITIL is not like a protocol like TCP/IP. So TCP/IP is an implementation of a model, but not the model itself. That's not the implementation. So one of the things that we've learned is that there are a bunch of silos out there, and the Pentagon has silos. A lot of them, they have DMARCs for who runs the network, who runs the desktop, who runs the server, who runs the platform, who runs the network management. We've got, and who runs security. All of these are one of many silos. And what we call business technology integration is the ability to do cross-silo collaboration, whether it be system design, whether it be metrics and monitoring, whether it be network documentation. So let's just take network documentation for a moment. If you have network diagrams, as I travel around and look at various places, I walk in and invariably I see diagrams on the wall, and most of them are labeled, 2008, 2007, 2010, and they are typically, dated and that sort of thing. I don't know why they'd still be on the wall, but nevertheless, it's probably because they haven't been updated. But it's an interesting thing. If you take all your business silos and your desktop silo, your network silo, your application and platform silos, and if each one of them build a network diagram or a system diagram, and to take those and lay them horizontally from the client to the server and the application, could put those things together and say, okay, here's the desktop, here's the network, here's the WAN, here's the secure infrastructure, and here's the platform, and here's the application and all the dependencies, and could you put your finger on the diagram on the left and give a troubleshooter an end-to-end diagram? I don't think so. And in case in point, when we arrived at the Pentagon, we came into a room and we started, okay, first thing we need to know a little bit of the lay of the land. It's kind of a gulp. And they said, we have a great network documentation system. However, it was one of the servers impacted in the disaster. So basically, and they didn't have anything printed out because it was online for ready reference. But don't forget, sometimes those systems go down. Probably a good idea to have the recent version printed out somewhere so that you can refer to it. So we started with a blank whiteboard and started diagramming. And who had to do that diagramming? Well, the key technologists that had a lot of other things, a lot of other fires burning. We came to help, but because these key technologists had to help us understand so that we could bear a hand and start helping them, so have more people helping, they were out of their key duties. It's incumbent, make certain that your key technologists are documenting the systems and that you are training everyone so everybody knows the key elements of the system. We're going to talk a little bit about that. But that's one of the examples of how organizational silos need cross-technology collaboration teams to pull together documentation that's congruent, gives you an end-to-end picture, and network monitoring metrics and that sort of thing. So back to the art of war. Sun Tzu and the Art of War is one of the books that is studied by most military officers at one time or another. And the bottom line to this is know yourself and know the enemy. And that's a fundamental thing. If you know yourself, you can react to things. And so in the area of knowing yourself, we need to develop end-to-end cross-technology, cross-silo documentation. We have literally hundreds of people who are willing participants in optimizing our network systems and applications for the end users. I find secretly that some of the people who come to the table a little bit later, the people come in the last few months, they're not going to come and tell you, hey, I'm really impotent because I don't know where anything is, I don't have a diagram, you don't have a diagram. They're not going to come tell you this. It is one of the biggest lost productive areas that your organization has. You have hundreds of people who are willing participants, but yet are impotent to participate because there is very little true end-to-end cross-technology, cross-silo documentation, so that when there's a trouble ticket, then first of all identify the client, put their finger on the client network, and then start moving to the right and into the network and see the network infrastructure that they're dependent upon. And they can move their finger to the right and see the firewalls and load balancers and WAN optimizers that they're dependent upon for that system to work. And then they can move over to the right and look in at the data center and the data center distribution and into the virtual platform and into the virtual image that they're running, and then virtual switch, and then on in that process that they're connecting to, and then back into the application, and then the application having secondary responsibilities or tiered capabilities. And now you have the ability for a help desk person to kind of understand your infrastructure and very rapidly isolate and at least triage where the problem may or may not be. And then you can see what network management. You can see test point 1, test point 2, test point 3, test point 4. You can visualize your infrastructure. So probably the number one thing that I would stress is that you must know yourself. And if you don't have that, it's costing you orders of magnitude more than you think, and a lot more than it would cost you to put these systems in. Now, once you have that cross-technology, cross-silo documentation, and everyone can meaningfully participate, then make sure you train everyone on the design constraints, your architecture, and certify them on your system architecture, your abilities, your capabilities, your constraints of your architecture, so that they're not trying to go in and modify to make it look like wherever they came from previously. You want your architecture to be pure and to work systematically with all your various components, and it's important to educate everyone on that part. Now, things and an example of something that we've done inside large-scale environments is to help people develop scalable cross-location, cross-domain data collection capabilities. Today, you have so many firewalls, load balancers, locations, different domains, different security levels, etc., that you can't just go out and do discover your network and then map it. It's difficult. And if someone can, they can do it in one area but not in another area. So our philosophy is you pull all that information from a variety of sources into a single repository across the organization, and that becomes your what we call network rendering database. That database becomes a repository, and you create a SOA. To the right there, you'll see a SOA so that other corporate systems can come in, so that you can export to your network management systems to make certain that you're monitoring all of the various dependencies of applications and systems. On the left, one of the things that when data goes into that R&R database, one of the things that we do is make sure that it has the correct endpoints on it. When those systems have the correct endpoints, when those objects, your network management objects, your route port objects, your switch port objects, when those objects have ends placed on them, you can do, reconnection of those objects. But when they are simply an object and don't have two endpoints, it's really difficult. So just populating a database without those endpoints connected on both sides isn't going to do you good. You're not going to be able to export them. We've designed a way of when that stuff comes in, we put the endpoints on them, and then we connect the points and populate a Visio diagram so that you can see your details of your network infrastructure port by port, a logical and visual way to get the VLANs and the virtual machine information so that a troubleshooter can truly see the environment that they're trying to troubleshoot. So that's one particular way that we like to see things done. Now, the second thing is know your enemy. Your enemy is root cause, the problems that you have. So you want to perform formal root cause analysis whenever possible. If your help desk solution is to always re-image, reboot, or reload, that's problematic. Take a moment. They should take just the opportunity for a moment to make sure. I'm not saying leave the problem go forever, but I'm saying, resist the temptation to reboot a server, okay, or even an end-user workstation until you've had the opportunity to collect a little bit of data. That data doesn't have to be analyzed right there at that moment, but can be put together as a collection of information, trace files, etc., to then do analysis retrospectively. So a lot of folks have some of those capabilities, but I'm saying that you need that. You involve your help desk in capturing those sort of things so that the recurring problems are able to be diagnosed and then obviated. Hey, the best solution to any problem is not to have it in the first place. Unfortunately, few are motivated with such things. Management needs to know how many trouble tickets you've closed, how many problems you've solved. Well, wouldn't it be great to say, because we were so proactive, we obviated the problems? Of course, at that point, you lose your justification for the tools and systems and people. But truly, that should be the objective of any senior management person, is to obviate and have all your technologists actually there, but kind of like the Maytag repairmen, without a lot to do, but when the problem occurs, they're there to help. The part of it is the ITIL problem management analysis, going out, finding out your statistical number of problems that you have. At the Pentagon, when we arrived there, they were getting right about 100,000 SNMP traps a day. Well, since then, they've started a filtering mechanism, and it was so overwhelming, 100,000 a day, that they were not able to respond to the ones that were the most critical and severe. So they learned that, okay, if you're going to have 100,000 SNMP traps a day, probably better figure out which ones are your most material, which ones are your biggest ones, and how to go about taking a look at that. Now, the third thing that I want to talk about in problem and change management is that I go into organizations and I find something that's amiss, and all we have to do is change a few parameters or repurpose a couple of existing systems or capabilities. And invariably, they look at me and say, well, we have no way of promulgating this optimization. We have a way to put this to control and have a fix. We either have to have an emergency crisis that's burning down the building, or we have to have a multi-million-dollar procurement in order to promulgate and have a set of steps in which we can do change. So, my recommendation is to make sure that you have a way to implement free changes that are not procurement or catastrophic kind of response changes. There's many free ways of improving things. I was at a site a few weeks ago when their entire internet access was very slow, and we went and we diagnosed the exact cause of the problem. We tested, we implemented, proved it mitigated, and they looked at me and they said, but we have no way of ending this change to thousands of our users. Because no way of linking it unless they've made a $3 or $4 million procurement to any ability to change their infrastructure. Anything that would cost free mechanism by which you can implement and repurpose your systems with just a few process changes. So I'd recommend that you think about that. Make sure you can do things that are free. The other thing is that a master plan. Now, after the Pentagon disaster, these guys were prepared. They had master plans. They had, in the event of plans, they had future plans that mapped the way forward and took our documents and other things that we learned and a fresh realization of the threats and vulnerabilities, and they integrated that in rapidly, and they took that forward, and Congress actually allocated $500 million to beef up the vulnerabilities of the Pentagon. And that wasn't because they just wanted to, Congress wanted to spend money. It was because the people who managed the Pentagon network infrastructure had an articulated strategy, and they knew where their threats and vulnerabilities were. They had it articulated in a well-articulated plan that allowed them to move that forward and to get champions within Congress and within their leadership in order to accomplish these feats. If you don't have a master plan, what you're doing today, your environment, and you have a disaster, what's going to happen is you're probably just going to rebuild in the same way that you were before. And that's, of course, going to be a few generations behind. And then the way that we talk about today, if you've seen those insurance commercials, it's like, man, your car is totaled, we're going to give you the same 1974 Pinto station wagon. By golly, you're going to get a 1975 Pinto station wagon in replace of your old car. So the same thing here. If you have a well-articulated plan and there's an emergency or a problem or an unfortunate situation and you have to rebuild part or all of your infrastructure, if you have this plan, it's an excellent place to start, and it's a good thing to do. So the thing is, decision support metrics. Well, remember all those systems that were given 100,000 S&MP traps a day? Which one's important, which ones aren't? Well, we're all S&MP traps of yesteryear. The red, green, not working or working. And today, it's more about performance. So what we call decision support metrics is developing a collaborative cross-silo management capability, validating your end-user application capabilities with signatures so that, your monitoring systems should be validating any potential changes. So talk about change control. If your monitoring system is monitoring all of the vital signs of your key mission-critical applications, you make a change, it's going to tell you, boom, immediately, you have a problem affecting one of your end-user application or capabilities. Okay? So that takes a lot of care and feeding. And the secondary thing about good decision support metrics is that you know right where your users are slow and things that you obviously can't optimize without a project. You have a whole list of projects that are out there that you would like to spend on. It's spent in every area, storage, network, and every part of your infrastructure, your budget would be depleted rapidly. In today's day and age, you use decision support metrics to identify your bottlenecks so that your portfolio spending can be pinpoint, so that you can take what you learn from those metrics and you can apply them to your budget allocation, your resource allocation, and you know that you are going to get a return on investment that is worthy of the money that you're spending. And today CIOs have an incredible problem. They're asked to upgrade in forklift fashion across the board. It's cost prohibitive. You can't do it. So even more so today, we need to have decision support metrics that are helping us prioritize exactly where we're going to spend the money and quantify the return on investment by identifying end-user signatures, by identifying the dependencies and the process flow of the application, and especially when you're starting to talk about cloud. Gives me a whole nother thing to talk about, and we'll do that another day, the dependencies and the vulnerabilities of moving to cloud, or cloud and then cloud to cloud. You know, how are you going to analyze those problems? We'll talk about that at another date. Okay, so performance indicators. You know, you've got net flow to go back and forth for rate and flow information to find out if certain applications are working. So network flows, you have device status, that's your SNMP, what's going on with your components. Do you know that your executives and your business leaders do not care about the status of a router, a switch, or something? What do they care about? They care about the capabilities and the abilities of their people. In the war environment, commanders don't care that this link is down or that link is down. What they want to know is, can we carry on certain command functions? Can we? And so we have to translate our performance indicators from what we're comfortable with, which are, you know, router ports and switch ports and links, into what our executives and our end users care about. Where am I impacted? Who is impacted? What applications? And what capabilities do I have or not have to run my business or my command on? So, you know, then knowing what that path is between the client and the server, and the response time at the server, and the latency going back and forth, and the ability to capture those transactions across your network, very important. So, in talking about pinpointing and multi-tier, I'd like to just mention that, you know, we have good decision support metrics. You can see that the process, you know, in other words, the CPU of your web tier, or the CPU of your app tier, or your SQL tier or mainframe tier, or your security authentication is consuming most of your response time. By having that multi-point, multi-tier transaction analysis, the ability to know exactly what is slowing down your end-user transaction, okay, that allows you to spend in the right areas, diagnose in the right areas, and serve your end user as well. Now, back to the technical systemization, right? You can go on our website. We've got this model on our website of our technical systemization, which, you know, there are thousands of things that you need to do. There are hundreds of procedures and processes, but these 6 things, we believe, if you do these and you get these built into your culture of your organization, people can remember them, they can focus on them, it's not too big. We have to implement all of ITIL is overbearing. All the ISO standards, overbearing. But when you say, hey, our organization is going to implement these 6 fundamental things, and they become the pillars of your ability to operate. And so these are the things that we believe are important. So just a little bit about the company. Some of you know me and have worked with me before. Those who don't, look forward to that potential opportunity. We are dedicated to crisis avoidance. We want to help you eliminate the problem through integration of best practices in your organization. But if you have a problem, our technical services are here to provide you immediate response technical services to help you resolve problems, mitigate issues, and then perform assessments to find out, you know, where you might be vulnerable. If you're in a proactive state, if you're looking at spending, you know, money on infrastructure or decision support metrics, we can come in and help you assess and help you, you know, build those things out. Our cornerstone services will come in and help you with an embedded analyst so that they can help you promulgate these type of virtual teams into those various areas and improve and benefit your entire infrastructure. In summary, documentation, documentation, documentation. Maintain a highly skilled technical staff. You may have a lot of vacancies. Prevailing thought is that vacancies are more valuable than the average employee. And it's better to have a vacancy than it is someone who is of average. If you have average people, you need to build them into highly skilled technical people so that they can materially, and part of that is the CIO's job to make sure they are empowered. Have that master plan, employ problem management and change control, dynamics, decision support metrics that drive your portfolio spending, business technology integration to make sure you have a collaborative environment, and then those virtual teams that help you. Virtual teams are implemented without any reorganization. So if your organization is ineffective, you apply virtual teams to address certain problems and pick the right people from each one of those, and you can change your organization and improve things without even having to reorganize. And then finally, be an end-user advocate. Make those end users your priority. I'm Bill Alderson. It's nice meeting with you today. I respect your time and energy. Appreciate you coming along today. If you have any questions or comments, please email me, Bill at Bill@Appolytics.com. So appreciate you stopping by today, and we look forward to talking to you in the future. I'm out, Bill Alderson.